Okay, so let's talk about where all of this is going and what the heck we're trying to do. So at the first part of last chapter, or the first part of this chapter, sorry, last section we went through and we multiplied a whole bunch of polynomials. So the second half of this chapter is going to be undoing the multiplying. Now, normally the opposite of multiplying is division, but with polynomials, the opposite of multiplying is what we call factoring. So we're going to learn a bunch of different types of factoring, and today we're going to do the easy kinds of factoring. We're going to start by talking about the GCF, or the greatest common factor. Remember, I told you we were going to talk about that first distributive property problem that you did in the review? GCF, or greatest common factor, is the opposite of distributive property. So if you go through and you think about the largest monomial, which would be a number and a variable, or just a number or just a variable, so one of those things, that is in every term of the polynomial. And if you take that out, then you would be undistributing, or taking the distributive property back out. That's what we would call factoring out the greatest common. So how do we go about doing this? First, we go through and we look at all of the things that make up each term in the polynomial. So you'll notice here I have a trinomial, and that's three groups of terms. So I took each group of terms, so 2x squared, negative 4x, and 8, and I'm going to break them up into their smaller parts. So I start with the first one, 2x squared. That's 2 times 1 times x times x. Now, when I go to my second group, remember I want something in common if possible. So I might ask myself, well, does 2 go into negative 4? Yes, it does. So what does 2 times what makes negative 4? 2 times negative 2 makes negative 4. So this one's going to be 2 times negative 2 times x. That way I have a 2 in both groups. Same thing in this last term, I have an 8, and I want to say, is there a 2 in 8? Yes, 2 times 4 makes 8. So if you look in each of these groups, you'll see a 2 in each group. That tells me that my greatest common factor is a 2. When we go to write our answer, we're going to write it in factored form. And when we write it in factored form, we start with our greatest common factor on the outside. And then we write our parentheses, and everything else that is in each of the groups goes back inside the parentheses. So if you go back to my blue group, if I took out the 2, what's left is a 1 and an x and an x. So that's just x squared. In the middle group, if I take out the 2, what's left in the middle is negative 2 and an x. In the last group, if I take out the 2, what's left is the 4. So in my factored form, I have my GCF and then whatever's left in the inside here. We're going to do another GCF problem in our examples, but basically that's what you're looking for. One, either number, letter, or combination of numbers and letters that works in each group of your polynomial. And you can do that for however many polynomial terms you have. So that's greatest common factor. Again, we'll do another example. The next part is factoring our easy trinomials. And I want to add a little reminder while we're still talking about greatest common factor. As we go through all of these factoring things, greatest common factor is the easiest kind of polynomial factoring, and it's going to be the most important. You are always going to want to look for that GCF in every factoring problem you do. Sometimes they won't have one, but they will want to have, if there is one, you will want to take it out. It will make your life so much easier to look for that greatest common factor first every time you do a factoring problem. Okay, so we talked about greatest common factor. The other kind of factoring we're going to talk about today is an easy trinomial. So what the heck is an easy trinomial? Well, an easy trinomial, remember tri means 3, is a 3-termed polynomial where the first term has a leading coefficient of 1. So it always starts with the number 1, x squared, 1, m squared, 1, b squared, whatever letter you want. But it's going to be 1 and then the letter squared. That's how we know it's the easy kind of trinomial. And remember, trinomial means it has 3 terms. So there should be the x squared term, the middle term, and then the constant term at the end. So How do we factor these kinds of easy trinomials? Well, if we're looking for things that multiply to this, we know we have to have an x and an x in both of our factors because x times x will make that x squared. If we think about going backwards, if we were multiplying two things together, we would want to do our firsts together, and that would be x times x to make our first term, which is x squared. So x squared gives us an x and an x in both of our factored forms. Now, then you're going to put two numbers in each of those parentheses. It might be a positive number, it might be a negative number. And you have to decide what those two numbers are going to be. How do you decide what those two numbers are going to be? Well, you go back to those diamond problems that we did because there's a relationship between those two numbers. Between the two numbers, they will multiply to make your constant or your last number. And those two numbers will add to make that middle number, that B number in the middle. Think about it this way. If you take the C value and put it in the top of your diamond and the B value and put it in the bottom of your diamond, you're trying to figure out what are my two factors that go and multiply to C and add to B. So here's a couple of examples for you. If I started with x squared minus 2x minus 3, I put an x in each parentheses because I know this x squared needs an x times an x. Then I have to figure out what these numbers are. Obviously, I've already filled this problem in for you. But how did I come up with those numbers? Well, I took this negative 3, that was my C value, and I put it in the numerator, or the top of my diamond. Then I took this negative 2 and put it in the bottom. And I said to myself, okay, what numbers will multiply to make negative 3 and add to make negative 2? If you did your diamond page correctly, then this should work out pretty well for you and should be pretty easy to see. So negative 3 and positive 1 are my two numbers that multiply to negative 3 and add to negative 2. So those are the two numbers that go in my parentheses with my x to be my factors. Your answer then would be this set of parentheses. So parentheses x minus 3, close parentheses, open new parentheses, x plus 1, close parentheses, is your second or is your final answer. Let's take a look at another one. X squared minus 15x plus 56. So again, I took my 56 and I put it at the top of my diamond, negative 15 and I put it at the bottom. What two numbers would multiply to 56 and add to negative 15? That would be negative 7 and negative 8. So when I write my factors, I have an x and an x to make x squared, and then my two factors, negative 7, negative 8. All right, let's take a look at 3 quick examples, and then I'll talk about your practice. So my first example is to factor out the greatest common factor from this particular equation. Notice I have lots of letters here and lots of numbers, and I'm trying to find one thing they all have in common. So when I look at my first group, that's usually the easiest place to start is your first group. You think to yourself, okay, what numbers multiply to make 27? Obviously, 1 and 27 make 27, but 1 and 27 are not going to do a whole lot. In fact, we want whatever else multiplies to 1 and or to 27, and I'm going to choose 9 and 3. So 9 times 3 makes 27, and then m squared is m times m, and then I have an n left in that first group. So all of that purple writing makes up that first group. Then I move on to my second group, negative 72 mn cubed. Remember, I already chose 9 times 3, so I want one of those numbers to go here in my negative 72. So 9 times negative 8 makes negative 72. That means we want to go with 9 times negative 8. Then I have 1 m and 3 n's according to mn cubed. Last group, remember I'm trying to stick with the 9. So 9 times what makes 36? 9 times 4 makes 36. Then I have 3 m's and 4 n's. That's a long one for sure. If you look at all three of those groups, we already talked about all three of those groups have a 9 in them. In addition, all three of those groups have at least one m. Some groups have more m's, but they all have at least one. So m also ends up being a greatest common factor. And if you look in all of those groups, n shows up in each of those groups as well, at least one n in each of those groups. Again, some groups have more n's and some groups have less, but we want at least one in every group. So when I look at my greatest common factor, They all have a 9, they all have one M, and they all have one N. That makes my greatest common factor. And you'll notice I underlined them so that when I go back to write my factored form, it's easier to tell what I took out and what I didn't. So here we go. 9mn is my greatest common factor. What's left in my first group? 3 times m. What's left in my middle group? -8, and then 2n, so that's n squared. And then in my last group of 4, 2 m's and 3 n's. So I have m squared and n to the third power. Now for all of these, you can double check to make sure that you did your problem right if you multiply your answer and get the original problem. So if I wasn't quite sure if I did the problem right, I would go through and I would distribute all of this and hope that I got the same problem that I started with as my new answer. This 9mm with the parentheses is going to be my final answer in form. All right, let's take a look at two factoring problems, easy trinomial factoring problems. So this first one is just a straight up easy factoring problem. Notice I have a 1 in front here, so I know that's how it's the easy kind. I take my 3 and put it as the product. Remember, at the last number is always the product. And then my +4, and that's my sum. And I say to myself, okay, what two numbers multiply to 3 and add to 4? And that's 3 and 1. Don't forget those n's to make that n squared at the front. So here's my answer, n plus 3 times n plus 1. Again, if you wanted to double check and make sure you're doing it right, FOIL this out. Hopefully you get the same answer that you started with, and then you know you were on the right track and you got the right answer. I had another person ask me too if they could write the +1 first and then the +3. That's certainly fine. It's the same answer. It would all count correct. So the order of these things doesn't matter. What will matter is if you change the signs. So if you had -3 and -1, that would not be okay because that would give me a -4 in the middle. Or if you had 1 minus and 1 plus, that would not add up correctly. So you need to pay really close attention to those signs, but which factor comes first in which parentheses is not a big deal. All right, our last problem is GCF and factoring the easy trinomial. So I know that there's a 3 in this first term, and currently we don't know how to factor anything with a number in front. We'll talk about that in this class. So if I have a number in the front, that kind of might be a heads up that I need a GCF. So let's think about if our GCF was 3, then I could take the 3 out of this first group and have r squared left. If I took a 3 out of 24, then I have an 8r left. If I took a 3 out of 21, then I have 7 left. So my new factored form is 3 times r squared plus 8r plus 7. Now that would be great, except I could factor this even further. And so I need to think to myself, okay, can I find two numbers that multiply to 7 and add to 8? Why, yes, I can. I can think of two numbers that multiply to 7 and add to 8, and that's 7 and 1. So because this can be factored further, I need to drop down my greatest common factor and make two new factors out of that new trinomial. So I have 3 for my greatest common factor. R plus 7 is one factor, and R plus 1 is the second factor. All right, so hopefully that helps a little bit with some of your examples. There is a practice activity here on Desmos. If you remember when we did multiplying, it's a self-checking Desmos activity. So you're going to go through and you're going to see a polynomial on the screen. You are going to type in your factored form, and if your factored form graph matches up with the graph that's already on the paper, then you'll know you've been doing it right. So that will give you kind of an idea of how you are doing on those factoring problems and if they are correct or not. Uh, one of the things I want to mention about that practice is you need to type y equals before you type any of your factored answers. So if we go back, to that last practice problem, I would need to write y equals 3 parentheses r plus 7 parentheses r plus 4 or plus 1, sorry. So make sure that you type y equals in your Desmos activity answers, or else they won't graph correctly. So go ahead and complete this Desmos activity for your points today. Though you'll see an assignment on PowerSchool, and all you need to do is do the activity on Desmos, and I will put your grades on PowerSchool. So don't worry about the activity that's on PowerSchool. Just do this Desmos activity, and I will put it there. Make sure you use your actual name so you get credit for today's activity. As always, if you have any questions, make sure you contact me during office hours, 10 to 12 every day. We're going to do more practice on this next class.